Hello, everyone, and welcome to this webinar on PLM data migrations. We will be starting in about 10 to 20 seconds. Please stand by. All right. Well, thank you, everyone, for attending this webinar on PLM data migrations. My name is Mark Young, and I'm with XLM Solutions. For those of you who are not familiar with XLM Solutions, we consider ourselves a complete PLM solution provider. We've been around since 2005, so we're been 18 years providing PLM services and solutions to our customers and partners. We really pride ourselves for being highly respected in the PLM industry for both our business and technical expertise. We always keep up to date on latest trends and best practices, both from a business point of view and a technical point of view in the industry. We are a Dassault business partner, along with a SolidWorks certified professional service company, an AIRS partner, and recently not listed on our slides are also an OpenBOM partner as well. Again, we dedicate ourselves to always being on the forefront of providing excellence and quality with the work we do, and making sure we're incorporating the latest trends and technologies in what we're doing. And as today we're going to be talking about PLM migrations, we really provide all aspects of PDM PLM implementations, everything from discovery workshops to general implementations, installations, customizations, integrations, data migrations as we're talking about, and then training and support. So let's get into the meat of the presentation. So once again, we're going to be talking about PLM data loading strategies. And when anyone has a data migration project for loading data into PLM, at the onslaught of it, it can be a pretty daunting task. It's easy to say I have all my data in one system, put it in another system, but as I always say, the devil's in the details how that should be moved over. That being said, with diligent planning and testing, the process can go smoothly. And today we'll talk about our strategies, methodologies, best practices to ease that migration pain. So we'll talk about when we're breaking migrations or doing migrations, we really break them into two parts, kind of a extraction where you really need to analyze the existing system, and then an import into the new system where you might have multiple data loading options, and then actually executing the project itself. So we'll go through all those steps. And let's start first of all with one of my favorite slides, talking about analyzing data to be loaded. So before any migration starts, we really need to do a good analysis of what data we're being dealt with and how we want to load that into the new system. So I like to break that down into four main buckets of areas to look at. The first, this general looking at the legacy data. What type of data are we dealing with? Is it files that are in folders? Is it data coming from a legacy system like a PLM system, which usually has a database and a file vault or a file store behind it? Every once in a great while, this is probably more current 10 to 5 years ago, but sometimes we still deal with hard copies, a filing cabinet that has a bunch of images that need to be scanned and loaded. And then the types of data. For example, in many cases we're migrating CAD data, which deals with links between the CAD data, whether it's model to drawing links, parent-child links, or in context links. There's a lot of relationships that need to be factored into it. Or we're dealing with more, what I'd say flat files like Office, files, image files, PDFs, etc. Or maybe we're just loading metadata. Maybe there are no files behind it. We're just going to load, items or BOM structures. So really having a good understanding of what that source data is and what does it, encompass. Then, we need to make sure, as mentioned, part of the migration is exporting that data out so it can be imported. So we really need to understand how we can export it out into a format we can use. So first of all, our old source is available to the database. We recently worked on a project where one company was being sold to another company, and they needed to export the data out of the company, or a part of a company was, let's say, being sold to another company. So the source company had access to all the data, and the company that was being sold, we needed to export the data, but they didn't have access now back to the source system where that data was. So we had to work out a method to get access to it so we could export the data. Sometimes, we may not have expertise in all these legacy systems out there. So sometimes we, even need to bring in third parties, or someone needs to bring in a third party that has that expertise to help out on that data export. Missing data, there's times where we know for one reason or not, the data is lost, not there, or could be corrupted. And if so, how can we handle that? Can we put in rules or logic to maybe deal with it? Can we go back to, older backups to get to it? But, it's one thing to say, here's the data, but there's another thing to say, all the database data is there, but all the files in the vault, could be missing. So we need to, anticipate a possible issue. And like you said, sometimes we will bring in additional experts to help out in very, unique situations. Mapping rules. So this is key. Like I said, it's easy to say, take all the data from system X, this legacy system, let's call it Smart Team, and put in a new system, like 3D Experience. But, they're different systems. So you really need to go through a mapping exercise and understand how the data will be mapped. How will the properties from the legacy system be mapped to the source system, such as part number, description, revision, created by, reviewed by, review date, whatever those properties are, we need to understand how they will get mapped in the other system. State mapping. So usually when we're doing a migration, files, especially if it's coming from a legacy PLM system, they have a state like checked in, released, obsolete, in work, for review. And we need to understand how they'll be mapped. Maybe the files coming from a folder system have no state, but they should be mapped to different states when going into the new system. So what should those rules be? Revision conformity. So again, a lot of new PLM systems today, require revisions to be in a certain format and meet that revision pattern, that is configured in the PLM system. So if your legacy data, have revisions that don't meet that format, how are you going to load them? Are you going to change those revisions? Are you not going to load them? Do we need to go through an exercise to understand what revisions don't conform to the new revision pattern and clean it up? So, again, we need to understand that rules. And then again, usually in modern PLM systems, data gets loaded to a type or a class. There's different behaviors around the different types of data being loaded. And what are those rules? How are you going to map the data to the possibly different classes, whether it's a document, an item, a manufacturing item, a vendor, And then there could be, subtypes or classes within it. If it's a document, is it a CAD file? Is it a SolidWorks file? Is it an AutoCAD file? Is it a prototype item, or is it a production item? So how are you going to map to those different types that are in the system? Links. So usually there's links not only between, CAD data, but there could be links, for between folders and projects. There could be links between different CAD systems. There could be links between documents and items. So how do you want to handle those links, and how will those links get migrated? And then, there's always maybe special logic that we need to handle. If the legacy system has workflows, is usually we consider that as a special migration to be handled differently, because there's all sorts of data that goes around with workflows and flow processes and engineering changes and engineering releases, etc. So, how are you going to handle other special situations that may not be covered? For example, we just had a customer that was looking to merge, TIFF files into one multi-sheet, TIFF or image file during the migration. So in their case, they had each sheet of a drawing was its own TIFF file, and instead of having a file for each sheet of a drawing, we were going to merge them together into one document. Or maybe transforming revisions from numeric revisions to alpha revisions. So what other special rules or logic do we need to play? We really need to define that from the beginning as well. And then finally, data volumes and load times. We need to understand obviously how much data we're dealing with, and have a good understanding, what will be that migration cutover window. Can we migrate everything over a weekend? Will it take longer than a weekend? And if so, how are we going to handle that? Do we need to do a delta migration for various reasons? So understanding, what window do we have to do the migration, and, how long it should take to do it is key to understand at the beginning of the project as well. So with every data migration project, there's always data cleanup that's involved. And, regardless with how many people feel their data's in the best shape and, extremely clean, usually there's always issues. And, part of the project may be going through a cleanup exercise. So, you can have multiple files that have the same part number, or files with the same file name that have different part numbers. Which one are which? Are they truly just duplicates in the system and only one needs to be, migrated, or do they actually represent different objects and, we need to clean it up? People made mistakes. Missing or incorrect file attributes. I always say the key attributes are, part number, revision, and description. Well, what happens if they're missing, or you don't have correct values in them? Or, if description, in the new system can only be 50 characters, but you have descriptions beyond 50 characters. So, understanding how that metadata is, and if it's, correct or missing, and how to deal with it. Incorrect or file association. So dealing with CAD data, do we have bad links? Whether it's, in a file system, a lot of times you can get bad links, but even in PLM systems, you can get bad links. So the link from the model to the drawing is missing, or the children, references are missing or not in the correct location. Dealing with SolidWorks, we have issues with, the link also references the configuration name, and the configuration name is not correct. In some systems that we migrate to, there are certain characters that are not supported in the file name or the configuration name, and perhaps those need to be identified and cleaned up. So, dealing with the data is critical. And then, talking about metadata, not only may it be metadata coming from a database, but it could be metadata associated to properties within the files that should be looked at. And then there could be, again, non-conforming revisions. You could have released assemblies with non-released parts, or latest assemblies using non-latest parts. So there could be, again, a lot of analysis that goes around, do these assembly structures make sense? And then, like I said, missing mandatory attributes. So there's a lot of data a lot of potential issues that could cause issues down the road with data migrations. But there's ways to identify that and clean it up. We actually have a lot of utilities out there that can help analyze the data and then report back on issues. Sometimes we can automatically fix the issues, but sometimes just identifying the issues are half the battle, and then people can be assigned to fixing them as necessary. As I've been alluding to, when doing data migrations, systems behave differently. Your legacy system most likely will behave differently than your target system that you're migrating to. So you really need to analyze that and do the data mapping exercises. But you don't really want to reinvent the wheel as well in your new system. So you really need to understand how the new system works, how it's designed, and then factor that into how you want to migrate the data. And some key things to consider are file access. Who will have access to the files? How are you going to search for the data in the new system? What will be the permissions? Who needs to work on data? Who needs to modify data? Who needs to just search data? Who needs to release data? What are the license implications? Maybe you want to migrate all the data into a certain type or class in the destination system, but if you do that, it requires you to buy more licenses or a different type of license. So that may affect something. Understand how metadata is going to work, and is going to be mapped, and workflow states. So it's really key to understanding how you want the PLM system, the new system, to work first, and then work backwards with those mappings without necessarily reinventing the wheel. And again, we can help come in and provide advice on understanding how your new system is going to work, to figure out what would be the best migration path forward into it, and how to best do those mappings based on our expertise. With any migration project, I would say this is a little bit out of scope, dealing with processes and how you're going to use the system. But it's a great opportunity as you're moving to a new system and moving your data over to really review how you're working today. What are your business processes today? And then, work on, improving them in the new system. It's a great opportunity to evaluate and update your users' experiences. So, as I said, don't always do the same thing, but implement that new system based on how you want to work in the future, and handling issues and challenges that you have today. Make sure that the new system will be able to overcome them. So use a migration project as a way to also update your processes and update the ways you work. That being said, any changes that you do may affect how that data needs to be consumed or looked at or viewed, and that may require data transformations while we migrate the data. And anytime you migrate data, you may migrate it the first time and say, great, now we want to change something in the new system as we see how the new system behaves with the data in it. And if you do make changes to the new system, such as changing the data model, you really need to verify, the migration process, because even a small change could affect the overall migration. So let's get into data extraction. As I said, for most migration projects, it's broken down into two parts: a extraction from the legacy system, and a import into the destination system. So whoever is doing that migration should really have familiarity with the legacy system, to understand the best ways to get that data out in the most efficient way. Usually if it is a legacy system, there's a database behind it, and most databases can be reversed engineered. So if you have direct access to the database, you can write necessary queries to extract the data in a format you need to get it out to be migrated. So even if you don't have familiarity with the legacy system, if you do have access to the database, there's a good chance you can reverse engineer it and get it and be able to get the data out. And again, that's what we do in many cases. If there is no database out there, or maybe it's a combination of database and files. So within files, you can also read the properties directly and then read the links and the relationships between the files. So sometimes when you're extracting data, you're just extracting it from a database. Sometimes you're just extracting it from files on a folder structure. And sometimes you're doing both and combining the data together to be imported. And, just to give you a list, there's many systems out there that we've worked with, that we've done migrations to and from. So I remember from Smart Team to Novia Matrix 1 3D Experience, DBWorks, Autodesk Vault, SolidWorks PDM, Meridian, SharePoint, Eris, OpenBOM. Windchill is missing from this list, but usually if there's a system out there and it's a PLM system, we're familiar with it and we can migrate data to it or from it, basically. When you're extracting data, there's different ways to extract the data. In many cases, we'll extract it to a neutral file format or an XML file, and then use that neutral file format to then import it, or have our tools read it to import it into the destination PLM system. Sometimes these destination PLM systems already have tools for importing the data, and the data needs to be in a certain format for the destination system tools to import it in. So we'll extract it directly to the format that the PLM system can read and import it in, kind of removing a intermediate step if necessary. And then, as I mentioned, as part of the extraction, it's a good time to do transformation as well, whether that be merging, TIFF files, converting alpha revisions to numeric, combining, in a legacy system, we've seen Title I, Title II, and Title III fields, and we want to merge them all together to just a simple description field. So, there could be a lot of different areas where data may need to be manipulated or transformed during the migration. So now let's say we extract the data out of the legacy system. Now we need to import it into the PLM system. And there's different ways to go about doing that. One reason, and it's fair to say, is a manual. Just have maybe some interns or lower cost employees literally copy the data out and import it into the new system. Sometimes a brute force method is cheaper and easier than an automated vendor. Sometimes there's vendor specific import tools. So many of the major vendors out there have tools out there to be used to import data into their systems. And in those cases, those tools are usually QA'd by the vendor. And if there's issues, you can go back to the vendor and say, hey, here's a bug in your import tool, fix it for me. That being said, a lot of the vendor specific tools are more generic than specific, meaning they'll do 80% of the migrations, but 20% of it may need specific or custom scenarios that the tools don't handle. They might need to be augmented by additional services, code to augment something that they don't handle. Another method to load data is directly loading that data to the database itself. So most, again, modern PLM systems today have a database behind it, and you could write directly to those databases. Now, that in those cases, it's very fast to do because you're just doing it directly at the database level, but you really need to have an exceptional level of understanding how that database structure works, because you're bypassing any rules or constraints that the migration tools might apply on it. So you really got to, the benefits for doing it is if you have a large amount of data, you can load it really fast, but you really need to perform a due diligence to make sure you understand that database structure. And you are doing a little bit at your own risk. If you load all that data and it doesn't work, I'm sure the vendor will say, you didn't load the data correctly. It's your fault. We're not going to support you. Where if you used one of their tools, they should support you if there's issues with the data. And then custom tools. Again, custom tools can support any requirement that you have with the data migration or transformation. They may take longer to develop and support, but may meet or get you that 20% of the way where a vendor-specific tool doesn't handle it. And in a lot of cases, a combination of all options are used in a migration project. It's not necessarily one side fits all. To talk about some of the different PLM systems that we work on, you'll see that many of the PLM systems that we work on do have out-of-the-box tools, based on types of migrations you're doing. So 3D Experience has what's considered EDAT or XPDM to load data mainly for on-premise migrations. They have what's called XTA or a Transfer Assistant tool for loading into on-cloud migrations. And then things can be augmented with different web services along the way. So there's obviously methods out there. SolidWorks PDM, another system we work with, they have what's considered their SolidWorks XML import tool to load data. There's drag and drop or direct DB updates, which are very useful in loading data. And then they also have an API as well. Eris has a batch loader, and AML, which is their kind of language for manipulating and modifying data within Eris. And then OpenBOM has an import catalog wizard and web services again for loading data. So each vendor, or at least the vendors that we work the majority of time with, all have methods to allow migrations and transformations of data. When running migration projects, here are some points to consider. Again, a lot of it may be repeats of what I said, but as mentioned, you really need to handle the different data models between the legacy system and the new PLM system. Really map out how you're going to transfer, not only the data but the functionality between the two systems. Anytime we migrate data, we want to make sure that our customers can grow with new PLM functionality. So we never want to migrate data and the customer comes back and says, oh, I can't now use this new module, or I can't use this other functionality because how we migrate the data. So whenever we migrate data, we want to make sure it appears and behaves just like it was created using the the out-of-the-box functionality or the user operations to create the data. And then our goal is to conduct migrations over a reasonable time frame. Usually we look to do that over a weekend, so we can shut down the system on a Friday evening and then make sure the customer can go live on that Monday morning. Now the key is to make sure we can do the export, transformation, and import within that time frame. And there's ways to handle that, but if you can't, then there's other options out there. So again, we try to do a single migration, and usually that's faster. That can reduce cost of the migration effort. but sometimes there's too much data to handle it. If there is too much data, then we can do what's considered a migration, a delta migration, and there we would, migrate the majority of the data while users are still using the current legacy PLM system. And then after the majority of the migration is done, pick a weekend to just migrate the delta from when that large migration was done to the, to the time we do the delta migration, which usually would be a much smaller data set and then could be done over the weekend. Improving times, a lot of times hardware can be a major improvement for migrating data. So, it goes without saying today, but we want to make sure it's, there's SS, solid state drives available. We're not running off of spinning disks where the data is coming from or going to. Increasing memory, optimizing where the data exists. Maybe having one drive where we're reading data and another drive where we're writing data to, increase the input-output performance. In general, some migration processes, methodologies, and best practices. As we alluded to, install the out-of-the-box PLM system you're going to. Really understand how that works, out of the box. Perform your due diligence. Review your legacy system, determine what data you want to migrate, understand how you want to map that data and or reorganize it or transform it. Identify any concerns that you may have, and hopefully those concerns will be identified up front so they can be addressed at the beginning of the project versus, you find an issue at the last minute and then are scrambling to fix it, and then work on your cutover plan. We'll get into this, but make sure you have a test environment. You'll definitely need to test the migration multiple times. Understand what technology, will be used to migrate the data. There's different ways out there, different technologies used to export and import data. There's different ways to skin the cat. But again, we can, work with you to figure out what's that best approach to migrate the data for you. As mentioned, you're probably going to want to run multiple test cycles. On average, probably somewhere between 2 and 4 test cycles are done before, you feel confident doing a production migration. As part of any test cycle or data migration, and a lot of times this gets left behind, but data validation is critical. We need people to review the data and make sure it looks good in the new system. So usually when we're migrating data, we're looking at logs, what got migrated, what didn't, error logs, but it's also critical to look at the data actually in the system, take key assemblies and validate that they're good, validate that the metadata is good, the links are good, and report on it. And really we feel that the end customer should be doing that validation because your own data. You know what to look for and what files are important versus maybe not so important. Obviously you want to plan for a production rollout, make sure users are expected that they're going to be using a new system, that they're trained in the new system. Any software that is going to be needed for the end users are installed on their computers, and then obviously running the production migration. With any migration projects, there's always balance of timing, downtime for users, resources involved, cost, automation. So we're here to again work with you to figure out the best way to balance that effort. What might we can do to automate it, what may the end customer can do to lower cost. Do we need to increase the time to reduce downtime of users, or can we have a longer migration cycle, which may save again on timing and cost. So it's a balance, and we're here to work with you to figure out what's that's best balance throughout throughout all the various axes, to be considered when doing a migration. As mentioned, testing the migration is critical. So, make sure you test the migration. You're going to most likely run multiple migration processes, and tests need to be done throughout each of them. And you'll find issues. There may be issues with legacy data, where files are missing, links are broken, inconsistent revision schemes. Everything I talked about at the beginning that you want to check on, probably you'll find that also again when you do the migration. So you're going to find these issues and you need to fix these issues. Maybe you need to manually clean it up. Maybe you need to change your data loading rules. For example, maybe you have a field in the new system which is an integer field, but in the legacy system you have character data in it. So maybe you need to clean up the legacy data and remove any characters, or maybe you need to modify the new system to not make it an integer field, but make it a character field. Maybe you're going to run bugs in the migration tool or code that you need to address and fix. Maybe it's a data loading procedure. For example, if you're loading created by field, you may need all the users in the system first before you can associate the user to as a created by user. So maybe a procedure thing where, certain operations have to happen first before other operations. Make sure to document your migration procedures. Usually there's going to be multiple steps involved in the migration, and each step should be it should be documented what needs to be done, and automation of the steps should happen as much as possible. And then, through each migration cycle, you're going to test, you're going to find issues, you're going to fix issues. You may change how the PLM system works. You may change how your data being loaded is, and then test again. As I said, any small change could cause issues in the big process. So, make sure you keep on testing the migration until you can run through the whole process smoothly. Again, before the final migration, you want to do some pre-data loading planning. Document when the legacy system will be turned off. By now, you'll have a really good time of how long it'll take to load the data, so you'll know what that exact cutover can be. Understand, does that have to be done on non-business hours, which is usually the case, or maybe it's not as critical and can load it during the week. You should have your data loading process really documented now, and have those events and activities documented, and know who's going to do what, and as mentioned, identify the key personnel responsible for all parts of the data migration. There may be someone involved in extracting the data, maybe someone involved in importing the data, then maybe people after the fact, validating the data import, IT to support the whole process, etc. Though, with what I always say is with proper planning and testing, the final data load should go smoothly. Make sure to follow your documented processes. Allow buffer time to handle any unexpected issues. Murphy's Law always comes into play, and then be prepared to support users in the new system. In conclusion, we say with proper planning and testing, migrating data to any PLM system can go smoothly. Make sure you pick the best migration tools based on budget and timing. Follow your documented procedures. Allow buffer time, and be prepared to support the new users. And as I said before, the devil's in the details. It's really key, I can't stress this enough, to fully understand your requirements, the data sets you're dealing with, your limitations, the technologies being used, and set the right expectations. Mapping and understanding what's going to be done from the beginning is key. And then we say, we're frank in saying that normally you don't have 100% migration success factor. Now we aim for like a 99.9 success factor, but there could be a small percentage of errors where data for one reason or the other just cannot be loaded, and set those right expectations. But with that being said, anything's possible. Most data migration scenarios can be accomplished in a relatively straightforward manner. We have yet to see a migration where we couldn't handle it. So, it's, as I said again, migrations can be daunting, but when you've done enough of them, you can really break them down into the necessary parts to have a good plan to methodological plan to handle it and migrate the data. But with that, I'm going to say thank you and open it up for questions. It looks like we have some questions. Feel free to type in the questions, and I'll answer them accordingly. First question: do you experience a migrating file-based Inventor CAD file to SolidWorks PDM? So yes, we've migrated Inventor CAD file to SolidWorks PDM from a file system from Windows folders. There's ways to do it through drag and drop. There's ways to do it through import tools where you can read the properties in the Inventor files and read the links and relationships between the Inventor files. So yes, there's, depending on the scope and the data, there's various ways to get that Inventor data into SolidWorks PDM. It looks like there was a follow-up question about SolidWorks PDM again. Looks like they are doing it manually today, so if that works, great. But yes, there's definitely ways to automate it, and depending on the files, it probably could be done in days, not months. Another question involved around migrating unit of measure, and having that unit of measure quantity, I guess, in decimals versus integer. So you can have unit of measure and then quantity. Usually quantity is on the links or the relationships between the files, and depending on different systems, that quantity may need to be an integer, it may need a decimal, and sometimes maybe it's even a character. Some systems are more forgiving of what that value can be or not. And in those cases, that would be a unique situation we would need to address. But sometimes, again, it's the vendor that needs to tweak the system to support it. Obviously we can't change the out-of-the-box code of the system, but we could handle it in different ways, maybe creating another quantity field or putting that information in another place. Question asked, is there training available for 3D Experience EDAT and XPDM? We can provide training. We provide training on different aspects of 3D Experience and the other PLM systems we mentioned. So feel free to reach out to me directly after this call if you're looking for such training. One more question here. How long does a typical migration project take? So it all depends on what you want to migrate, how much data there is, what any transformations you need, where's the data coming from. But I'd say on average, a migration project from complete start to finish is 2 to 3 months, where a majority of that time is running tests and making changes to the migration process, but 2 to 3 months on average. All right, that looks like all the questions for now. Feel free, like I said, to reach out to me if you have any additional questions on the subject or input on the subject. I'd love to hear it. This video recording will be available to download, and after the webinar, a short survey will be presented, and I'd appreciate everyone to fill it out to provide some feedback on PLM migrations in general, and and possible new additional webinar topics. So with that, unless there's any more questions, I'll be here for another minute, and then I will end the webinar. Thank you very much.